Okay, so welcome to the end of chapter 2, reactions of alkanes. And one of these reactions you've already seen before, but first let me get into it. And I know I talked a little bit about this the other day or last class, but I'll just very quickly explain this again. A substitution reaction is also known as a single displacement, and this is when one functional group is replaced by another functional group. So you guys did this in lab 2, the synthesis of T-butyl chloride. You substituted an alcohol, a functional group, an OH, for a chloride group, a Cl, a halogen group. Substitution reactions are really, really important in organic chemistry. So we're going to kind of look at least 2 of these today. So the first one is something you guys did in chemistry 1120 or 1121 called oxidation. So oxidation of alkanes is very similar to oxidation that you learned about in electrochemistry. Basically, a carbon atom in an organic compound loses a bond to a hydrogen and gains a new bond to something else. We call that dehydrogenated or oxidized. So let me just show you a picture here. A very common example of this is the oxidation of an alcohol into a ketone or an aldehyde. So in this case, I have an alcohol, functional group, right here. And what's going to happen is it will end up losing hydrogen, which is, again, why they call it dehydrogenation sometimes. It loses a hydrogen. And then this oxygen here that was part of the alcohol gets a double bond to turn into, in this case, a ketone. Now you'll notice at all times, there are 4 bonds coming from that carbon. So 1, 2, 3, 4. Well, when I lose these 2 hydrogens, I still get my magic number 4 ratio. So 1, 2, 3, and 4. You always have to make sure that the carbons have 4 bonds coming from them. So again, when the alcohol on the left loses its hydrogens, that oxygen becomes double bonded. So really, you don't need to know much about this. What I'm trying to get you guys into is the big reaction here, the combustion, which you do have to remember. And I'm going to show you how to do that. But combustion is an example of oxidizing a hydrocarbon. So if we started with something like on the left, we have methane. As it slowly gets oxidized, it turns into an alcohol and an aldehyde, now a carboxylic acid, and then finally, this is carbon dioxide. All right, so as a hydrocarbon continues to get oxidized, we keep adding bonds to oxygen. And I don't know if you guys have ever heard of, from chemistry 1120, incomplete combustion. Incomplete combustion is when it doesn't completely oxidize. So you're not getting all of the carbon and oxygen burned. So what you guys are expected to know today is how to balance or write combustion reactions, something you've done before in chemistry. Might seem like a long time ago, 1120. So the combustion of propane is a classic one that you guys have probably done in 1120. I just want to show you a question. You might see a question like this on your test, wink, wink, the combustion reaction for pentane. All right, hold on one second.
Mister?
Yep.
We need a wink review before the test.
Yeah, I can do that before your test, no problem. Probably next Thursday before the test, I can go over some of that. All right, so the combustion reaction for pentane. Okay, so step number one here is you have to actually figure out, well, what is the chemical formula for pentane? Well, pentane is a 5-carbon chain. So I know that I know the formula is C5H12. That formula is N and then 2N plus 2. Now, what if you forgot that? So say you're doing this on a test and you completely forgot the formula or how to figure out the molecular formula of pentane. Well, if you know that there's 5 carbons, and I'm just going to quickly draw this and then erase it. So 1, 2, 3, 4, 5. You can count the number of hydrogens. So this one would have 3 hydrogens, 2, 2, 2, and 3. And if you add them all up, you'll get 12 hydrogens. So if you can't remember molecular formulas, it might be a good idea to just remember what these look like in their structural formats. So now that I have my formula, C5H12, I can actually do this reaction. And this is straight from Chemistry 1120. All we're doing is we're mixing in a little bit of hydrocarbon chemistry. So combustion, C5H12. This pentane could be a gas or a liquid. I'm going to assume because we're burning something that's really hot. So there's the reactants of every combustion reaction. Now, this is going to completely oxidize and turn into carbon dioxide. We're not dealing with incomplete combustion here. So remember your formula. It's a hydrocarbon plus oxygen will give you carbon dioxide and water. Now, my assumption is I'm burning, so this is combustion. So I'm going to take everything as a gas. The only challenge for you guys is to balance this. Now, so first let me do the word equation here. We have pentane plus oxygen gives me carbon dioxide.
And
And
how
of
the how
course,
is gas not liquid?
sorry?
H2O.
I write gas for H2O because if this is a combustion reaction, we're dealing with very high temperatures. Like if you have a flame, you're definitely hotter than 100 degrees Celsius, which would boil water. So I like to say that the water is in the gaseous phase. All right, so let's get this guy balanced. Now, let me pick a new color here. Okay, so I like to start, this is again the hardest part. I like to start with the carbons. So I have 5 carbons on the left, so I'll put 5 on the right. Hydrogens, I have 12, so I'm going to need to put 6 here to give me another 12. Now the challenge is oxygen. So over on the left side, I have 2 oxygen. On the right side, I have 10 plus 6, or 16 oxygen. That looks like 20 on the left, doesn't it? I'll say, I'll go 2 ox, 16 ox. Okay, so the challenge is now I have 16 oxygens on the right, and I only have 2 on the left. So what I need to do is figure out a number that I can multiply that 2 by to make it become 16. And the answer is 8. 2 times 8, or 8 times 2, is 16. So this is review. And I know it might seem like you did this a long time ago, which you probably did. It was probably in 1120, but you might get asked something like this on a test. I like this for 2 reasons, because 1, you have to know how to write the molecular formula of a hydrocarbon, and then 2, you need to remember your reactions. So I only have 3 slides left. I am going to put myself on pause, and I would like for you guys to write the combustion reaction. 1, 2, 3, 4, 5, 6. This is a hard one. It's because it's 6 carbons. But I'm going to see if you guys can remember this. Look at this maybe more as a challenge than a practice problem. And I'll be back in 2 minutes, maybe 3 minutes for this one, and we'll look at the answer. All right, so we'll be back in 3 minutes. All right, so like I just mentioned, this is a tough question. I counted that it had 6 carbons, and just remember that every carbon is going to be bonded to 3 other things, or well, sorry, to 4 things total. So this is 3 hydrogens, 2, 2, 2, 2, and 3. The other way you can know this is that it would be the number of hydrogens is twice the number of carbons plus 2. So this would be C6H14. So that's step number 1. All right, here we go. So step number 2, C6H14. Just finish the formula. Even, guys, if you can't get this balanced, as long as you get this formula down, you're going to get most marks anyways. So combustion is always the hydrocarbon plus oxygen gas, and then CO2 and H2O. Again, guys, I don't care what phase you write for water. I've always done it as a gas because this is a hot combustion. If you put liquid down, I don't care. But like one of the easiest ways to answer this is to just put everything as a gas and not worry about anything else. Okay, so let's get this guy balanced. Now, guys, when you're doing this, you want to have an eraser. Try to not bring a pen to your labs or your test. You should be using a pencil because I'm going to need to erase some things here. So this is just temporary. Okay, so it's okay. 6 carbons. I'm going to put 6 carbons here. All right, what about my hydrogens? So 14 hydrogens. All right, so I'll add 7 here. So, okay, my carbons and hydrogens are actually balanced. But here's the problem. On this side, I have 2 oxygen, and on the other side, I have 12 plus 7. I have 19 oxygen. So now I have a problem. I'm trying to get that 2 to turn into a 19. It's near impossible. But what you can do, if I want to turn this 19 into an even number, the easiest way to do that is to multiply everything by 2. And Niam just said it in the chat. Yeah, times everything by 2. So I'm just going to erase my red part here. And this is why I told you it's important to use like a pencil or an erasable pen. I'm going to multiply everything by 2. So basically, I'm going to put a 2 here. And now think about my balancing again. So I have I have 12 carbons. So I'll put 12 here. So I got 12 because 2 times 6 is 12. I have 28 hydrogens. 2 times 14 is 28. So I can just put 14 here. Now let's look at my oxygens. So here I still have 2 oxygens, but over here I have 24 oxygens and another 14 oxygens. So I have 38. Woo, that looks crazy. But now I should be able to figure out a number times 2 would give me 38. And the answer to that is what? 19. Whew. So this one, guys, is tough. I probably wouldn't give you one like that on the test because I'd rather you not excuse me, waste a lot of time balancing a equation that you would have learned how to do in chemistry 1120. So you'll probably be getting something a little bit more straightforward than that one. Like something like pentane is a really good example. It's nice and easy. We don't have to worry about multiplying everything by 2, for example. So just make sure you know one of these or how to do one of these for your test. All right, I have 2 slides left, and that's it for today. And you guys don't really have to worry about this type of reaction because we will come back to this in chapter 3. So we're going to look at this in chapter 3. And the reason I say that is because alkenes and alkynes are very easily halogenated compared to an alkane. Alkanes aren't that reactive, but with a nice and reactive halogen, maybe some other conditions like some heat or some energy to help it along, we can actually replace a hydrogen on an alkane with a halogen. But we'll come back to this mostly in chapter 3. It's not very common that we would have a reaction besides combustion with an alkane, but this you'll see a little later in chapter 3. This means heat or light. And what that means is to get methane, for example, to turn into chloromethane, you need some sort of energy into that system. It's not energetically favored, so it's not necessarily going to happen. But when we deal with alkenes, it will be really cool and really interesting. All right, so I'm going to hit stop record. That's about it for today, guys, because we are done chapter 2. We finally finished it. If you have any questions,